Okay.
again, no? Uh, Web development is the process of building and maintaining a website for the internet or an intranet that is accessed through a web server and hosted on a server, either on uh, on premises hardware or in the cloud. So this include everything from single plain text web pages up to the complex web application. So web programming, also known as web development, is the creation of dynamic web application. So example of web application are social networking sites like Facebook or e-commerce site like Amazon. And a lot of people learn web coding because they want to create the next Facebook or find a job in the industry. And of course, the three main type of web development, of course, the front end development, back end, and full stack, no? And of course, uh, web development, no, create and maintain websites. So they are also responsible for the site's technical aspects, such as performance and capacity, which are measures of website speed and how your traffic the site can handle. And they are responsible for the look and functionality of website or interface. So to give us more details about the topic, let us all welcome our presenter. Take it away, sir.
So good morning, everyone. So today I'm going to have the what we call is implementing model-driven architecture. So as a series of the discussion with the present reporter, we already realized now what is actually what is XML, what is the purpose of the XML, how does it take what we call here a data from how does it travel through the protocol called SOAP, no? And actually, the as Sir said, no, internet is sending data through packets, and it is also important for us to distinguish, no, an internet from the device itself. So what I'm going to discuss today is actually the what is MDA overview and the sample infrastructure and also the model transformation and what is an MDA approach. I'm so sorry dun sa sound natin no, kasi medyo nag-aano yung aso sa labas. Alright, so anyway, to make this actually this MDA is originated from OMG. Um, as a first reporter just discussed, no, what is OMG? It was actually founded in 1989. Just to give you a simple recap of that, which is a consortium of 800 companies in the world. Accomplishments of common, actually, one of the some of the accomplishments of this what we call OMG is this what we call common object broker or request broker, which plays a very vital role in this what we call web services right now, because this what we call Cobra is an architecture of infrastructure that computer application used to work together over the networks. Now, they also this is the actually succeeding the past reporter also discussed this what we call the unified modeling language or the UML and the meta object facilities. So actually, the meta object facilities, this is actually the technology that we are using right now in terms of this what we call data warehousing, and then the XML metadata interchange. Now, so the XML metadata interchange is the one who's responsible of giving data from one system to from one programming language to another programming language. Just like Sir just example, just in just one network, we are actually talking to a very vast system which is composed of very different and various programming languages. All of these standards contribute making idea, model, and development in reality. So, all right, to know more, actually, I just posted the reference that I just get in. Where did I get the facts? Now, why models? Okay. Actually, when we say model, model is an abstraction of a system and a part of it. Depending on the type of the model, it can provide simple views, systems, and more detailed one. In some software engineering models have long a rich history. So designers often use models for planning their projects and explaining them to someone. Now, basically, since that going back to the history itself, no, we have different types of models which makes a significance right now because most of the software engineers are using it. Okay, which try to make them to look forward into the automation itself. Okay, these models are normally simple sketches and don't contain any relevant information, by the way. Now, in this aspect, what is the problem? Okay, usually when we were working in a software project, the requirements are often written in documents, bullet points, and scenarios. Frequent just pictures with four annotated details. No, so in other words, no, these are the documents itself. No, and you know how hard the documentation is. But in the long run, um, programs are almost always, actually this is the important part, programs are always a source for code in a programming language and a bug reports are kept in the database or logs. So meaning to say, no, when we are updating no, our system itself, the documentation no, ay naiiwan yan. So um, kaya we do have a hardship in how hard it is to document time after time if there will be a system update, no, especially in the database part, no, if there will be a glitch to the database or the data itself, the behavior of the data, you have to document it in order for you to do that. Now, but none of the relationships between these parts of the project is usually stored. Okay, so this possibly the automation of the task and does not provide any consistency between the various aspects in the software project. This problematic as especially in case of refactoring and reusing of a project or even extending one. This is where the model-driven development comes in. Okay, so what is a model-driven architecture? All right, so it is an approach to software development that uses a single source and contains all of its information. It also, it traces the programming of an higher level abstraction. Okay, and the MDA defines the standards of model-driven development. MDA provides also the guidelines of structuring software specification models, and this is the most important because MDA should be a vendor or middleware neutral. Now, an approach to IT specification that separates from the system functionality and specific implementation of the functionality and the particular technology platforms. So in other words, you design it once, and once that you have designed it, no, it will going to be implemented or build it onto any platform. Okay, so that is how self-sustaining the MDA model should be. Okay, and the model is a formal specification of data. All right. Okay, so uh, the main goals, ito yung ano natin, no? The main goals are simplifying, standardizing task activities, including the project life cycle, and to maximize the automation of the mapping. So as you can see, no, the previous reporter, no, discussing the web services. Now, if we would just imagine the web services, it is actually one system to another system incorporated to another system within the another system, no. So in that aspect, no, if you would just imagine how vast it is and how it is very difficult to maintain, then I guess it will be uh, a number of person that you're going to need in order for you to maintain that. Now, the goal of the MDA is you have to simplify things out, okay? And because of this, you got this what we call the simplicity is beauty, no? Kasi we do have an old adage, just like the simplicity is beauty. Okay, now, since that we already the previous reporter just discusses no, how the soap transfers from one system to another system. Sometimes it could be in the what we call here the use of the RESTful API if you do have an API itself, and through the help of the XML. Now I'm going to have this infrastructure. So we will go into discuss the three main types of artifacts under the computation yung ng MDA, no. We have this what we call computational independent model, or the CIM, and we have the PIM, which is the platform independent model, and the platform specific model. So the computational independent model describes this what we call the business domain. So sabi nga dito, the model, this is the business domain where we get the requirements itself, the physical overview of the classes that we're going to use. Now, the platform, it is actually a model which the software architect is using in order for them to identify all the classes that is involved which will be passed into the platform specific model. So while the platform specific model, no, it is more on the hard what we call it, the hard coding, no, the hard coding itself, and how do we translate it into codes. So okay, so ito pala muna yung una. All right, so in this case, as you can see here, we have this what we call the computational independent model, which is described by the business analyst to describe the business. So the business analyst will go to interview the business itself and know the requirement. After knowing the requirement, no, it will be passed into the software architect in order for it to model what would be the translation of the business going towards to the program or to the system. And from the system itself, it will be chunked down to the platform-specific models, which will be dealing with this what we call the team leads, which will be distributed among the groups of programmers in order for it to be translated into code. So how does it translate into code? So as you can see, no, this is actually the platform, no, specific model that I just used to research using the Atlas transformation model, transformation language. Actually, it is not the only software that we are using in terms of us making this language now profitable. And also there's ano pa ba yung mga language ito? Meron siyang tawag na Viatra. But basically it is actually a legacy software, so that's the reason why it's very hard for us to get the details. But the point here is that if we would just look the diagram itself, no, it describes how does the model converts into the program. So as you can see, in making this program, there's a series of this what we call abstraction and the encapsulation itself in order for you to have this one. Okay, so if you would just see the program itself, it uses the encapsulation method, going towards the abstraction to call from one function to another function. So this is how the transformation goes. Okay, and later we will go to demonstrate how does it go. No, okay. Now in MDA, it also this set of what we call the levels of abstraction, meaning to say how does it convert from the assembler, now from the assembler itself, which is the lower programming language, going towards to the from the machine language, which is understandable by the machine language, and going towards to the translated into pseudocode to perform a textual development. So using this one, it will be created in a model itself, and model-driven architecture will be created on that. Now, this is actually what I'm trying to show you right now, guys, is basically I believe this is an AT&T, AT&T's integrated software, on how do they function. So a common structure appeared. This is actually bi-tiered. See, just like the Sir Dean Nelson Mina is trying to talk about, the layered tier of services. How do they interact and how do they communicate with each other? So the narrow layer separates the communication. This one, okay. This is actually the services that communicates from middle from the one middleware to another middleware, which supports the three programming language, which is the Java, Python, and C++. Okay, and it also which connected to the database support. Basically, sometimes they are using hindi sila direktang kumukonekta dyan because, because of this what we call security reasons. And how do they connect? They are the database is sending request. This platform sending request in order for them the database to respond dun sa gustong dun sa nire-request na data ng mga software na ito. Okay? So, and sometimes they are using this what we call stored procedures. So yun yung most of it. Pero ang alam ko sa Microsoft, para more on encrypted files na sila pagdating sa mga database itself. Okay, separates out from the data, the functional and technical architectures itself, and provides implementation and technical architecture. The container, okay, which is the containers, this one, the container components is used to implement the foundation and the technical architecture. And the developers writing applications are concentrated in adding a specific additional. So meaning to say, because of these what we call components, yung nag-a-add na lang ng mga enhancement to the program itself, para mag-update doon sa requirement ng services na nire-required in the client itself. Okay, so the containers, all right, so the containers, the containers are responsible for providing the components, which is, sabi nga ni Sir kanina, ni Sir Dean, it is considered as what we call helpers. So helpers, if I'm not mistaken, dun sa pagkakarinig ko. This one is the containers, and the responsible in providing this So how do they communicate each other? As you can see, iba-iba yung programming languages because of this what we call SOAP. And this SOAP is actually nakasakay siya dito sa tinatawag natin services. Okay? Yun. And the major service are themselves implemented in a series of layers. Okay? So, ito po yung layers natin. And naka-tier po siya. And each service access helper presents an interface to the developer that is designed to be easy used and independent from actual implementation to the underlying service. Service access helpers in turn, okay, reference toolbox to obtain access in underlying. So, yun. And some components actually using Cobra, yung kanina nga i-discuss ko kanina, because of this what we call to integrate their structure, okay? For some other communication methodology. Kasi sabi ko nga kanina, the Cobra itself is an architecture of infrastructure that computer application used to work together over the networks. Okay, so sometimes they are using the platform of this what we call Unix, no, and Unix philosophy, which is the platform. Sorry, the philosophy of Unix, no, writing in small details, no, and combining it from one program to another program in order for it to function as in a specific system as required, no. So, and they are using pipes and scripts to perform this complex task. Okay, so most of the tools are chaining. So, yes, sabi ko nga kanina yan. And service tools may be shared across multiple components with the container or private to a single component. Most service tools are implemented so that they may be also used and either shared to the private services. So as you can see, no, what you are seeing is actually the inner side of this. Okay, how do they communicate? No, as stated, the components has been associated toolbox that holds the individual services. However, the component itself does not see the toolbox as it is entirely contained within the technical structure. All component level access to services is through the service access itself. Yun nga, yung sinasabi ko kanina, yung request, no? Through request, hindi siya directly kumukonect dyan. And in addition to holding the services tools, each tools contains information about the component that is needed in one or more services. Thus, the service tools do not need access and the component to the component and obtain this. Okay. So in general, now once that the appropriate service tools have been written, changing from one communication to middleware package to another is simply matter of switching service tools. Since service tools are chainable, it is possible to simultaneously load the service tools for multiple communications and middle package. Now, this can be used when integrating the legacy systems because we all know sa mga industry practitioner natin, we all know how hard it is, no, to connect with this what we call the integrating yung tinatawag nating legacy systems, because we would be relying on the output itself para makakuha tayo ng data, no, which will be served as our input for our system that we are developing, the system that we are developing. So, because containers can retain access of each component tools, it is possible to instruct the containers to dynamically alter the set of tools in the toolbox. So, engineer may chain and additional service tool onto the service access for a given component or even replace replace one service tool with one another and component in its operating. Ayan. So the model transformation, ito po yan, no? So meaning to say, from the domain specific itself, it should have the translator which will compose of this, it could be a system, it could be a software that will convert, no, into a platform model. And then from the platform model, using the same translator itself, it will be converted into what we call the platform specific rules and platform specific models going towards the executable codes. Now, and using those software, no, should have a capability, no, to convert from one program to another program, and serves as a translator, no, for the request that is sent from one program to another program. So we do have this what we call MDA approach. Okay, the MDA approach is executive. Okay, so ang kagandahan ka sa approach na to, no, na distinguish natin kung ano yung perspective ng executive, okay? And yung para doon sa business, the architect. So as you can see, these are the different level up to the technical layer itself, papunta doon sa business layer o doon sa executive ones. Now, they are also, kung titingnan naman natin yung pababa, no? This explains yung tinatawag nating the what, how, where, why. So, yung pag sa what, no, yung tinatawag nating inventory sets natin. And then, kung ano-ano yung mga components na dapat natin ilagay. And then the process, how it goes, no? And also the pagdating sa where, no, yung distribution networks, where are we going to distribute it, no? So, from what department to another department are the primary links of this particular system. And the responsibility assignments, no? So it is dedicated to the to the who aspect, no? And when is okay, yung frequency nung how do we provide yung mga deliverables, and of course, no, yung and why. Ang maganda kasi diyan yung why, kasi it explains the rationale of why do we have to do that. So yan yun. Now, yun. All right, so there's a disadvantage. Sabi nga natin, there's always a two side of the coin. So since that this is actually the MDB introduces a lot of rigidity. Bakit? So dahil the models are only flexible to the aspect where the flexibility has been designed. No? So, ibig sabihin, hindi natin kasi from the structure itself na pinakita ko sa inyo, no, ay, we are very limited lang doon sa area na po pwede nating i-improve. And because of this area, no, it will go back to the perspective model. Ibig sabihin, si technician itself should have to go to the permission of the engineer bago niya magalaw yung particular system, no? So the modeling environment doesn't always support version. Let's say for example, si C++ nagkaroon ng bagong support version, no? So it will take time for them to update, no, those three systems na nakita natin kanina, just like for example Java linked with C++ and linked with this what we call yung Python, ano. So it will take time to adapt. Okay, of course it will adapt, pero it will take a lot of effort and time to consume para magkaroon ng adoption. Now the tools, the modeling tools approach is almost finished at the start. The requirements teams needs to understand and it is allowed on what not. Teka lang. So meaning to say dito, no, ibig sabihin, no, in a different perspective, itself, no, they should understand, no, how will it be delivered, and who are the how to answer the what, how, where, who, when, and why itself. No? Now, okay, writing the software is labor extensive, no? And with each new technology, much work needs to be done again and again. Okay, system never built or using only the technology, and the systems always need to communicate with each other. So the problem is the continuous change of the requirements. Now, in that productivity problem, no, ito naman yung medyo mahirap sa kanila, no? Most of these are paper-based diagrams and text kasi nga model nga siya, no? Which loses their value when coding. Now, and lower level updates whenever it is need for the change of correction. So let's say for example, no, yung may mga level kasi ng updates, kunyari yung mga database itself, no, hindi mo naman siya isasama doon sa system. So kaya lang yung frequency nung pag i-edit niya, pag-change, no, it takes a lot of an effort to have, no, because document, pero during the updating, no, ito yung nauuna kasi yung system bago i-update. Pero ang ideal talaga dapat dyan is, dapat i-document muna yung magiging update, and then update, the act of update, and then after that, i-document mo ulit kung ano yung naging result ng update. No? So, ganun ang dapat na documentation, which is nale-left behind yun because most of us, no, yung mga programmers, no, naka-focus tayo doon sa coding itself. No? The modeling environment doesn't always support version control. No? The modeling tool approach almost finish at the start. Okay? Ay, parang bumalik. Hindi ko na na-update yun. So, ito na pala yun yung na-discuss ko na kanina. Sorry, hindi ko po na-edit. No? So, okay, so this is my reference, pero before I go back, no, I'm going to demonstrate something, no, para at least mas maintindihan nyo. Okay. So stop share lang muna ako, mag-share ako ng bago sir. Okay. And all right, so this one. All right, so this is actually a software, no, which converts from one a legacy software that is used for the in the industry. So as you can see, pasensyahan nyo na trial version lang ako, no, na kasi kinuha ko lang to doon sa friend ko na galing doon sa sa company na pinanggalingan ko before. All right, now in this case, no, okay, so we will going to discuss yung how does the PIM converts with PSM itself, no? So in this case, okay, we will going to add some models itself, no? Let's go to the new model, pattern. Sorry. Ayun. So we will going to describe it as, nakikita niyo po ba, mga sirs at saka mga ma'am?
Apa.
Okay. We have this what we call the PIM, right? Platform Independent Model, PIM. And okay na yan. Sige, yan na lang natin. Okay. The PIM. Ayan. So, default lang naman. I-close na lang natin para lang maipakita ko sa inyo how does it goes. And we will going to have a new model, also the PSM. So the PIM is very different from the PIM kasi the PIM itself, sorry. Teka lang sir, wait lang. Okay, and new model. Ano yung package pala tayo? Yung package. Sorry, this one is PSM. PSM tayo. Alright? Which stands for medyo mabagal yung computer ko. Dami kasi, kailangan kasi mataas yung requirement ko dito. Alright, so ito yan, no? Ayan, PSM. So as you can see, no, we just created based dun sa class, no? Nakapag-interview ko na. And we will be now creating a class under the PIM. Okay? So under the class of PIM, let's say for example, gawa na lang tayo ng simple diagram itself, no? Yung UML. No, class na lang. Class, right? Ayan na. Ayan na siya. Trial version po siya. So in this case, no, magkakaroon lang tayo ng we're going to have the two classes, which is the student and the professor. Okay, so this one class natin, this is the student. Sorry. Alright, so ito yung student natin. Ito, student. And also, we will going to have the class, inherited class ID. Alright, so association. The association of this class to another class, which is the professor itself. Okay. Now, in this particular concept, no, kung mapapansin po ninyo, no, yan na yung dalawang class natin, no, and so basically, we will going to create. This one is is managed by, okay, so is managed by, okay, so na lang natin. So as you can see, no, the professor is, the student is managed by the professor. So yan yung ano natin, yan yung UML natin. And sometimes, no, meron tayong relationship itself, no, yung multiplicity na tinatawag. It depends upon the setup. Kung ito ay classroom setup, no, many students are managed by one professor, di ba? Pero kapag naka-university aspect siya, many students are managed by many professors. So gawin natin siyang university concept. So many is to many. So ginawa natin many is to many. Many is to many. So yan. So dahil nakapag-create na tayo ng ating model, no, we will going no to convert it, no, and transform it, no, sa PSM. So how do we do this? You click the design and then you go to transform. Right? And then ito, kung mapapansin niyo, pwede niyang i-transfer sa C#, yung code, no, yung concept, pwede niyang i-ano. Pero what I'm going to do, no, i-click ko na lang muna dito sa mid-level natin, which is the DDL. Okay? So tinatanong tayo kung saan natin ilalagay, and ilagay natin sa PSM folder. Ayan. So do the transform itself. So as you can see, the transformation itself, makikita nyo na po yan, no? The DDL. So as you can see, nakapag-transform na po tayo. So pwede rin natin siyang i-transform into codes, no? Yung gigingan natin. So kung titingnan natin yung ating code, no? So as you can see, the foreign key, no, is associated with the primary key of the professor, now which is managed by, and this one is the foreign key of the student. This foreign key associated with the primary key of the professor, tapos yung foreign key papunta doon sa primary key. Okay, so I hope you learned something doon sa aking presentation, a simple presentation lang po doon sa ginawa ko. So, that would be all. Thank you very much, sir. Salamat po sa inyong time para pagbibigay ng time para makapag-report po ako.
Okay, so thank you very much. Sir, now I just want to add some additional inputs. Actually, Ma'am Jinky raised hand, sir. Go ahead, Ma'am Jinky.
Gusto ko lang po magtanong kay Mark kung anong klaseng application or model yung ginagamit ng mga 30 days trial.
30 days trial.
Uh,
Ano po to, ma'am, sa ano kasi sa Starks company to. So, sa Starks, ano siya, yung pangalan nito, yung ating, ito. So, start po siya, teka, yan na natin. Enterprise Architect, ma'am.
Enterprise.
Opo, Enterprise Architect.
Okay, thank you.
Okay, thank you very much, Madam. Okay. Again, in web system development, no? Testing is very important, no? Because again, testing is the process of assessing a system or its component with the goal of determining whether or not it meets the set requirements. So, testing is the process of running a system to find any gaps, faults, or missing requirements that aren't in line with the actual needs. So, organizations, developers, and individual sites or applications all have different level of testing. Another issue, of course, is the security management. No? Many security aspects are taken into account throughout web construction, such as data entry error, checking through forms, output, filtering, and encryption. Because malicious activities like SQL injection can be carried out by people with malicious intent, but only rudimentary knowledge of web programming in general. So, a script can be used to abuse website by allowing unauthorized access to malevolent individuals attempting to acquire information such as email addresses, passwords, and password-protected materials such as credit card details. And some of this is dependent on the server environment in which the scripting language executing, like or such as ASP, JSP, PHP, Python, Perl, or Ruby, and it is thus not always the responsibility of the web developer. So to avoid sub-attacks, it is recommended that web applications be thoroughly tested before being released to the public. If a contact form is available on a website, it should include a CAPTCHA field, not to prevent computer programs from mechanically filing out forms and spamming emails. Because new security holes are discovered in web apps even after they had been tested and launched. Security patch upgrades for widely used programs are regular. As a web developers, it is frequently tasked with keeping apps up to date to security fixes are issued and new security vulnerabilities are uncovered. And the server port hardening is the process of protecting a web server from infiltration. So when information is transported from one site to another on the internet, many technologies are used to keep it safe. Certificate authorities, let's say for example, offers TLS security, SSL certificates to help prevent internet fraud. So when communicating and storing sensitive information, many developers are various type of encryption, and a web developer's knowledge frequently includes a rudimentary understanding of information technology security risk. So I think that's it for the topic, for this topic.